Hello viewers, welcome back to my YouTube channel. In this video, you are going to learn about irrational numbers and how to represent irrational number in a number line. And we'll do a couple of problems in exercise 1.2. We already know that irrational numbers are those which we cannot be written in the form of P by Q. So there are numbers which cannot be written in the form of P by Q. Those numbers are called irrational numbers. There are a number of examples we can list here. So root 2, root 3, root 5, root 7. So these are the numbers we cannot express in terms of P by Q, where P and Q are integers. And pi is not a rational number, it is also a rational number. So here make a note of this point. Every real number can be represented by unique point in a number line. You already know what is number line. So number line is a x coordinate line where we can mark the numbers here and we can represent all the rational and irrational numbers in this line. So all the real numbers can be represented in a unique point on a number line. Let us take up one irrational number to locate root 2 on a number line. So to do this, you need a number line here. As you can see here, this is a number line. And as I told you, so you need to mark some points. I'll start with 0 and 1, 2, 3, 4, and same negative coordinate also -1, -2, -3, -4. So initially what you do is you need to take a scale. So I am going to take a scale of 1 centimeter is equal to 1 unit, and I marked all the units in 1 centimeter. Let us say it is 1 centimeter, and I just draw a line, a thick line here, and mark this as A, and this I represented as 1 unit. And from here you need to draw a perpendicular bisector. So you need to draw a perpendicular bisector for 1 unit. You need to cut a perpendicular bisector here, so and draw a perpendicular line which is also 1 unit and mark this as B. So join OB, you will get a beautiful right angle triangle here, and the hypotenuse of this right angle triangle is root 2. So how it is root 2? Again you go back to your fundamental theorem, that is Pythagoras theorem. So Pythagoras theorem states of hypotenuse square, that is OB square, in this right angle triangle. So OB square is equal to, so this is 1 unit and this is 1 unit. Let us write it in here. OB square is equal to OA square plus AB square. So OA square is 1 unit, I'll write 1 square, plus AB square is 1 unit, I'll write 1 square. 1 square is 1 and 1 square is 1. 1 plus 1 is 2. OB square is 2, and the distance of OB is equal to, if you take up this side, it will root 2 units. So hence we can write root 2 here. The distance OB indicates root 2, and if you want to make this in a number line, take O as a center and B as a radius. So draw an arc which cuts this number line. This number line, this point represents root 2, and let us say this is P. So this is how you need to do locate irrational number on a number line, that is root 2 on a number line. Let us take up another example, root 3. For this also, again you need to take a number line and start mark with 0, 1, 2, and equal distance. You need to take the scale in correct way. -1, -2, -3, -4. So you start with the basic, that is 0 to 1, 1 unit, and perpendicular bisectors 1 unit, and you know all this. So this is A, this is B, and the hypotenuse OB represents root 2. Now we want root 3 in our number line. For that, what you need to do is, from this point you need to mark perpendicular bisector and again draw 1 unit and mark this point as C. Join OC. This hypotenuse gives the value of root 3. So remember students, this is a right angle triangle OBC, and here this is a perpendicular line and this is also a perpendicular line. The hypotenuse OC gives root 3, and from O to C as a radius, draw a arc which cuts in a number line which gives the value of root 3 and mark this as Q. So this is how you need to locate root 3 on a number line. Again, we can use the Pythagoras theorem here. So here, this is C in fact, and this is B, and OB is root 2, and BC is 1, and you need to know what is the value of OC. So for this, what you do is again by Pythagoras theorem, OC square is equal to OB square plus BC square. OB square is root 2 whole square. BC square is 1 square. So root and square get cancelled. The remaining thing is 2 here, and 1 square is 1, that is 3. OC square is 3. OC is root 3 units. So we're just confirming whether we have done a correct writings here. So I have written here root 3, and how root 3 because of the Pythagoras theorem. So this is how we locate the root 3 on a number line. Let us go to the exercise 1.2, that is question number 1. So question number 1 says every irrational number is a real number. So the answer for this question is yes, true, because the basic definition of real number says real number is a collection of both rational and irrational numbers. So every irrational number is a real number. So every point on a number line is in the form of root m, where m is a natural number. This may not be true because I can say between root 2 and root 3 there are infinite number of rational numbers we can list. So hence this statement is false. The last one is every real number is an irrational number. Again, this is also a false. As I said in the last class, all irrational numbers are real numbers, but every real number may not be a rational number. It may be a rational number, natural number, whatever, integers. So those are all includes a real number. So every real number is not a irrational. It may not be a irrational number. So this is a false statement. So take the second one. Are square root of all the positive integers rational? So remember this statement. Square root of all the positive integers are irrational. If not, give an example. So very simple question. So I can say root 2 is a rational number. Root 3 is a rational number. But let us take root 4. You know the value of root 4. Root 4 is 2 only. So 2 can be written as 2 by 1, and this is a rational number. So all the square root of positive integers may not be rational. So this is an example: root 4, root 9, root 16, root 25. So these are the perfect square roots. We get rational numbers here 2, 3, 4, 5, and hence this statement is wrong. Locate root 5 on a number line. So you need to take a number line here with the same procedure which I have told earlier. Take points 0, 1, 2, 3, 4, and make equidistance -1, -2, -3, -4. And for root 5, you need to take a base of 2 units, because root 4 is also root 4 is the value of root 4 is 2, and root 5 is more than 2. Hence you need to take base value as 2. So mark this as A. Again, draw a perpendicular bisector of 1 unit and mark this as B. Draw OB, and this gives root 5, and just draw an arc to bisect this arc in a number line which gives root 5 on a number line. Mark this as a point B. And how to know this hypotenuse is root 5? Again, use the same formula. So OA here is 2 units, AB here is 1 unit. You need to find out the value of OB. So again, use the fundamental equation. OB square is equal to OA square plus AB square. OA square is 2 square, AB square is 1 square, 2 square is 4, 1 square is 1, and the answer is 5. So take this square to that side to give square root of 5. Hence OB gives 5 unit. So this is how you need to locate any irrational number in a number line. I hope all of you understood today's topic. Don't forget to like, comment, share, and subscribe. Thank you. Thank you, one and all.